Right, hello there. Welcome to Geometric Sequences, one of the last few topics on the Year 10 ASK for this year. So what I've done is this whole A3 sheet should be attached to the Go for Schools as a document as well. So you could print it out and go through it with me, or you can just watch this and see how it's done. It's up to you. Right, so geometric sequences are where it's multiplied, so where you have this key thing that terms are multiplied by something, okay, called a common ratio. So multiplied, whereas arithmetic are where they're added and subtracted. So arithmetic are things like your linear sequences where you have an nth term, and your quadratic sequences, okay, and they're different. So geometric is where it's multiplied. So which of these are geometric? Well, first one's geometric. You're multiplying by 4. So it's geometric and you are timesing by 4 each time. Second one is geometric. Now it's multiplied. So that's actually divided by 3. But instead of dividing by 3, that's the same as, I'll write them here because it looks better, multiplying by a third. So it's always multiplying with geometric sequences. This one is going up by 2 each time. So because it's going up by 2 each time, you're adding 2. So it's not geometric, it's arithmetic. Okay, so that's not geometric, that's geometric, that's geometric. This one here, you're multiplying by 10 each time. So that is geometric. This one here, it looks like you're multiplying by 11, but you're not. Multiply it by 11. If you multiply 88 by 11, you don't get that. So that is not geometric. This one, you're multiplying by 4. So that is geometric. Each time you're multiplying term by 4 to get to the next one. This one, what a famous sequence. 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5, next term would be 8. And it is Fibonacci. I cannot spell it, so I'll write fib. And that is not geometric or arithmetic. This one, you're reducing it by a tenth. It is geometric and your common ratio is multiplying by 1 over 10. This one, you're doubling each time, so your ratio is multiplying by 2. 2 times 2, 4 times 2, 8 times 2, etc. And this one, bit of a weird one. So to be able to tell, what you would do is try doing 4 into 36, which is 9. Then try 36 into 1444, which is not 9, and that into there isn't either. So it's just randomly being multiplied. It's not geometric. So that's that first section there. Okay, so to make a geometric sequence, fairly simple. You need a starting point, obviously, and then what I've been calling the common ratio. So first 4 terms of a geometric sequence given by the rule. Start with 3, multiply each term by 2 to get the next. So start with 3. So when n is 1, first term is 3. And multiply each term by 2. Second term times 3 by 2 to get 6. Third term times 6 by 2. Hang on, start with 3, multiply each one by 2, yeah. Multiply 6 by 2 to get 12. Multiply 4 by 2, multiply 12 by 2 to get 24. So each time you start with 3, double it to get 6, double it and double it again. This one, generate first 4 terms, start with -1 and times each one by 10. So start with -1, times it by 10, you get -10, times it by 10, you get -100, and times it by 10 and you would get -1,000. So that's fairly simple. Okay, more geometric sequences. There's really not much to these at GCSE. When you get towards A level and further maths, you look at the sum of geometric sequences, which is good. But at the moment, this is what we'll just cover. Find the rules. So we've got more where we're finding the rules. Here, multiplying by 3, times 3 each time. This one, multiplying each term because you're halving it, so you're multiplying. It's always multiplying with geometric sequences by half. This one, now look at the signs. positive, negative, positive, negative. So you're going to have to multiply by a negative number, because that's the only way of changing a positive to a negative and negative back to a positive. And the common ratio here is actually multiplied by -10. This one here, how are we getting from there to there, there to there, there to there? We're dividing, and it's actually a quarter each time. 24 goes into 96 4 times. So this one you'll be multiplying by a quarter. Now this bottom one here, you've got, look at the top and bottom separate. How do you get from 1 to -5 to 25? That's got to be a minus, and the ratio is going to be 5. You're timesing by 5. So -5 on top. How do you get from 3 to 9, 9 to 27? You times by 3. So your common ratio is multiplying by -5/3. Okay. Now, geometric sequences actually have a really good real-life use. A lot of things like bacteria, viruses, very relevant, and nuclear half-life and stuff like that is geometric sequences. So 99 cells every minute, each cell splits into 2. So the rule to describe it is you would start with 99 and your common ratio is multiplied by 2. It would double each time, which is fairly simple. Okay, this one, again, very relevant. Dave's got the flu, meets 3 people who also become infected. Each of those people then meets the next day and infects 3 new people. So each day, all the infected people meet 3 new people. Okay, so let's have Dave as 1. So then he meets on day 2 3 people. So times it by 3. On day 3, those 3 people each meet 3 other people. Times it by 3, you get 9. Next day, those 9 people meet 3 people. 27. Again, 81, 243. Look how rapidly. So that's day 1, 2, 3, 4, 5. After 6 days, you've got 243 have the flu infected by 1 person, Dave. This is why things like lockdown are put in place, and maths is behind it all. So that's geometric sequences, and goodbye.